Hello and welcome to a knowledge dump video for the brand new draft curriculum in the province of Alberta, the number skill related to fractions, decimals, and absolute values. I have it listed as number outcome 1. The program of studies does not number them, deliberately so that we don't get the impression that there's only one order in which to teach it. In this case, that's a good impression because I actually think teaching outcomes 2, 3, and 4 prior to 1 will make this one go a little bit more smoothly, even though this is the first I will be recording. I'm going to manually sort them after. I'm also calling it a knowledge dump. This is not the lessons as I would use them in class. In class, I'm going to have some slides that do the background knowledge before we introduce a new skill. So our program of studies, which I'll just quickly bring up here, each of these outcomes is categorized into knowledge, understanding, and skills and procedures. So they have various groups, various guiding questions, and so forth. What we are looking at here is this one with the absolute values. So I'm going to have 3 slides explaining this knowledge to practice those slides and make sure they work. In the slides that, as I would actually use them in class, they're all building to skills, and only the slides with the relevant previous knowledge are going to be included with the skill set. So that's just a little bit about the structure you can expect if you choose to follow these lessons. As a student, you may be inclined to use this as quick review because it summarizes everything. Learning is an active process, not passive. If you just read notes, it will not be anywhere close to being as effective as actually solving problems. If you need this as a quick review before diving into solved problems, go for it. But do not expect this to be the entirety of your studying. There are no practice problems in this video, and practice problems are critical for convincing your brain not to forget it. By default, your brain forgets everything. You need to convince it something is worth remembering. To do that, you access it, you apply it, you solve the problems. All right, our first knowledge dump. We're going to look at the relevant curricular outcomes and then our 3 knowledge dumps. The organizing idea here under number is that numbers are organized into systems with unique notation to communicate quantities and to facilitate calculations. Our guiding question: how can the symmetry of the number line contribute to a sense of number? Meaning, if you draw a line right through that 0 on the number line, you get positives on one side and equally spaced negatives on the other, maintaining the same distance from 0. Our learning outcome here is to analyze positive and negative numbers. Our key understanding, that understanding block in the middle of those outcomes, is that every fraction and decimal number has an additive inverse, or a negative, with the same absolute value and opposite sign. Additive inverse is the mathematical technical term. We think of it as negative, but some of these are positive. So the additive inverse of negative 3 is positive 3. If you start with negative 3, you have to add a positive 3 to get 0 as the answer. The additive inverse is just whatever you have to add to make the answer 0. Sometimes it's positive if you have a negative number. Sometimes it's negative if you start with a positive number. So, we're going to look at expressing negative fractions. It is not uncommon for numbers to have more than one representation in mathematics. The same is true for fractions. Specifically, negative fractions can be written in multiple ways because they can be created in multiple ways. If we calculate negative 1 divided by 2, we get a fraction with a negative 1 over 2. If we calculate 1 divided by negative 2, we get a 1 over negative 2. These produce exactly the same result. We can write it with the minus sign in the numerator or the denominator, or we can also just write it with the negative sign out front because it's still a negative fraction overall. I prefer this third and final form here with that negative sign out front. for purely aesthetic reasons. In mathematical terms, all are correct. This third one is the more common convention. Not all teachers deduct marks if you violate convention. Check with your own. If there's any doubt, write it in the third form with the negative out front. That tends to be the safest overall. If we look at the general form, that's a negative a over b is a over negative b is a negative a over b. The general form of a concept in math is all letters, no numbers. And using Euler's convention, those letters tend to come from the first half of the alphabet. They are parameters, not variables. So, negative numbers in the real world. Despite common attitudes to the contrary, all of the math we teach in public schools has real-world applications somewhere. Negative numbers, whether you write them as either decimals or fractions, have applications in the real world. One example is winter temperatures. The Celsius temperature scale sets the freezing point of water at, or around, depending on your local atmospheric pressure, 0 degrees Celsius. When temperatures get colder than that, they are represented by negative numbers. The Fahrenheit scale uses the freezing point of Lord Fahrenheit's father's pickle brine recipe for reasons that don't make a whole lot of sense in the general world, but that's where they came from. Sea levels. When tides go out, the local sea level can drop below average. When average is taken to 0, that makes them negative. Debts. If the money you have is a positive number, then debts are represented by negative numbers. Hopefully the total of what you have and what you owe is still a positive number. Changes. Any number which can change can be represented by the difference between final and initial values. When the values drop, these differences are negative numbers. I altered this a little bit. The program of studies specifically says stock market prices. I think changes in general are easier to wrap our heads around than the specific stock market example when we're looking at the grade 7 level. I don't know how many 7th graders closely follow the stock market, although it is something that they could find in newspapers, assuming that they still know where to buy them in print in your area. Our third new knowledge outcome is the definition of the absolute value. A useful quantity in mathematics is the absolute value of a number. This is represented by vertical lines around the variable or number. For example, the absolute value of x is an x with vertical lines on either side. The absolute value is the distance between a number and 0, and the distances are always positive. So positive numbers are unchanged. The absolute value of 5 is 5, and the absolute value of 17 is 17. Negative numbers become positive. So the absolute value of negative 5 is 5 because negative 5 is 5 units away from 0. The distance between negative 5 and 0 is 5. Similarly, the absolute value of negative 17 is positive 17 because negative 17 is 17 units away from 0. Now, one guideline, we calculate everything inside the vertical lines before applying the absolute values. So if you have the absolute value of 2 minus 7, we do 2 minus 7 to get negative 5 first. Then we take the absolute value of negative 5, and our correct answer is a positive 5. It is not correct to make that 7 inside positive and end up with 9. So just a warning now. We calculate everything inside the absolute value as though there is no absolute value first. Then we apply it as our final step. So if you have any questions or any feedback, please leave them in the comments. I will try to respond in a timely fashion. That is an invitation for students who are out there trying to understand this very content-heavy new curriculum, as well as for teachers who are looking for alternative resources because it's a very significant change in what's coming. So we're all in this together.